This is Mr. Anderson for Keller Community College with the last section of Chapter 8. More about graphing quadratic functions, and this time we're actually going to be graphing the actual quadratic function, which is going to be a squared plus bx plus c. Now this equation, ax squared bx plus c, is ready to go and plug into the quadratic formula. But in this case, instead of us doing that, we're actually going to be graphing it from what we see. Like the previous vertex form that we learned in the last section, section 6 of this chapter, if we have a greater than 0, then this is going to open up like so, and we're going to have a minimum value where the lowest point of that line or curve, parabolic curve. And this is going to be where if x is less than 0, then it's going to open downwards, and we're going to have a maximum at that spot right there. The c value is the y-intercept. That is kind of a nice little perk of the problem, and one of the ways to know about that is that if I put my x is 0, so what that would do is it would put in 0 for the x squared and a 0 in for the x. This would just give me a value of c, which means that that's all I would have, and that c value is the y-intercept of the problem. Now the vertex, we can find the vertex by taking our, at least the x coordinate of the vertex, by taking our b, which is the second coefficient, or the number in front of the x, dividing it by 2 times a, and taking the negative of the answer, and that will find our x coordinate. Then to find the y coordinate, we would plug this value into the equation. So a lot of times we see the vertex given as negative b over 2a, and then f of negative b over 2a, and what this is saying is it's saying that if you want your x coordinate, you take your b value, you divide it by 2a, and then you take the negative of that, and that will give you your x value. The y value would just be plugging that back into the equation, and that's what the f means here. You're plugging it back into the equation. But we're going to actually use our calculator for that, since we can find our x coordinates of our vertex very easily using negative b over 2a. We can just go to our table and figure that out. Thank you, technology. So my axis of symmetry is going to be x equals negative b over 2a, and then if you want to know your maximum or minimum point, we can obviously get that from the table, and we will. Now, the next part I'm about to do here is to show you how you could convert from the quadratic formula to the vertex form, remembering that the vertex form yesterday, or in the last video, depending on when you watched it, if you did watch it yesterday, this is a times the quantity of x minus h, quantity squared, plus k, and I woefully left an inadequate amount of space to do 3 problems in this one field right here. So what I'm going to do is kind of make a rectangle space, and I'm going to do one problem at a time, and then erase that and do another problem, erase that and do another problem, to show you how to turn the quadratic formula into the vertex form. So the first thing I'm going to do is take my problem here, my f of x, and take this x squared minus 6x and put this in parentheses, and I'm going to put a space for minus 1. Now what I'm going to do here is kind of like apply my completing the square rule, because to convert a quadratic formula to vertex form, we're going to complete the square. And it's kind of nice to do a little reminder of this, because we haven't done completing the square since the first section of this chapter in section 8.1. Technically the second half of section 8.1. So I have to say, to complete the square, and completing the square is taking your b, dividing it by 2, and then squaring it, and the b is going to be the number again in front of here. So 6 divided by 2 is 3, and then squaring it, so I'm going to add 9 here, but I'm also going to subtract 9. Since this is on the same side of the equation and not opposite sides of the equation, I'm going to have to put my plus 9 and minus 9 on the same part here. And what this is going to give me now is that this trinomial becomes x squared minus 6x plus 9, and this leftover part here is minus 10. Now this trinomial becomes x minus 3, x minus 3 quantity squared minus 10. So my y equals, or f of x equals, what used to be my x squared plus 6x minus 1 is now this parabola. And this parabola has a vertex, and if you remember this from yesterday, our vertex, or again yesterday, from the previous section, is going to be 3 comma negative 10. There's our vertex. Our axis of symmetry is going to be x equals 3, and since my a value is positive, this is going to be a minimum at y equals, or f of x is equal to negative 10. So you can see where we can, obviously this problem, I could have just typed it into the graphing calculator and gotten all this information, but just to show you that we can switch from quadratic formula to vertex form and back again if I foiled this and subtracted the 10. Make my rectangle here for problem 2. Now what we have here for problem 2 is we have a, now completing the square can't be done until you get the original x squared in the beginning of the problem to be just a normal x. So what I'm going to do, since I can't divide both sides by 2, I'm going to factor out a 2. And what this means is that in the parentheses now I'm going to have x squared minus 10x minus 3 halves. And I'm going to kind of like leave my parentheses gapped like this, since I need to fit a term in here to complete the square and its opposite value to keep it balanced out. Now completing the square is b over 2 quantities squared, so negative 10 divided by 2 is negative 5. Negative 5 squared is 25, so I'm going to have a plus 25 here and a minus 25 here. So my 2 still sits out in front. This trinomial becomes x squared minus, it doesn't become x squared, becomes x, sorry about writing the square, x minus 5 quantity squared, and the negative 3 halves and the negative 25 is negative 26.5. Alright, now that whole thing is getting multiplied by 2. We can distribute the 2 back to the inside, so I've got 2 times the quantity of x minus 5 squared, and this negative 26.5 gets multiplied by 2, and that makes a total of negative 53. So there's my vertex form there, and the vertex form is pretty cool because I've got my vertex now at positive 5, negative 53. My axis of symmetry is x equals 5, and since my x value, or my a value, is 2, it means it opens up, and so this is a minimum at negative 53. Alright, let's go and do the next problem here. Next problem going to be probably the trickiest of all of them because of the middle term and also the idea that you have to factor out a 2 at the start of the problem here. So I'm going to factor a 2 out, and that's, I should probably put my f of x first here. I'm going to factor a 2 out, and that's going to give me x squared, because to complete the square I need a x squared in front, minus 5 halves x, and then plus 5, again leaving space because I want to complete the square here and put its opposite value right there. Now completing the square is b over 2 quantities squared, so 5 halves divided by 2 is the same thing as multiplying by 1/2. So instead of writing 5 halves divided by 2, 5 halves times 1/2, this makes a total of 5/4 quantity squared. So this is going to be a total of 25/16, and I'm going to have to go minus 25/16 on this side here because these two have to balance out to make 0. So these first three terms, becomes a difference of, not a difference of squares, becomes a, we've completed the square now. And for some of you who wondered, like, I'm really not sure what to put here, you would take the square root of the third term here, which is going to be 5/4, and look at the sign from the front of the second term, and there's my square, and 5 minus 25 sixteenths on technology gets an answer of 55 sixteenths, which we're going to make easier because you'll notice there's a 2 sitting out in front. If I distribute the 2 to the inside, the first term becomes 2 times x minus 5/4 squared, and 2 times 55 sixteenths is, I mean, you basically could double the 55 and then reduce the fraction, or you could just divide the 2 and the 16. It becomes 55 eighths. So my vertex is going to be 5/4 comma 55 eighths. My axis of symmetry is x equals 5/4, and since my 2 is a positive value, this is going to be a minimum at 55 eighths on my y-axis, or almost close to 6 point something. All right, great. Well, that was that. Sorry about not having enough room there, but let's get to the graphing. And the graphing is going to be pretty cool because what I'm going to use, I'm going to use my little trick here that I learned, that my vertex is found, my x-coordinate is found by going negative b over 2a. And since, again, I've only given one graph here, I'm going to keep erasing this after every time I do this. You will probably in class be given more sheets of graph paper. But I first want to start off by drawing this on the screen here. I want to draw it on the calculator and show you what it's going to look like here. So let's go type it in. Let's go move the calculator into place. I'm going to say, let me turn this on, clear out your y equals, make sure you click your y equals key and clear it out. Go zoom 6 to put your graph back into the dead center. That's zoom 6, and that gets your window set back to normal. So here we go. Let's go with, oh, one more thing. Our tables might be a little different, so click on second window and choose your table start to be 0, enter, and your delta table 1, enter. So 0 and 1. So now what we're going to do is type in our y equals and go x squared minus 10x plus 21. And what we'll do is hit graph and take a look at that equation. You can kind of take an estimate where the vertex is. To me, it looks like the vertex is going to be around 5. So if you kind of take a look here, we go 1, 2, 3, 4, 5. If we go second graph, we can hope to see that symmetry point at 5. And again, if it's not evident on the calculator where we can see the symmetry, we're going to use our x value, which is our negative b over 2a. Which is negative b over 2a. So my x vertex is going to be negative 10 divided by 2 times 1, which is 2. So negative 10 is positive 10 divided by 2. Our x of the vertex is going to be at 5. And then what we do is we go to our calculator. Since we can plug 5 into this equation, 5 squared minus 10 times 5 plus 21, or we just go to the calculator. 5 is at negative 4, and then we have 4 and 6 at negative 3. So here's 6 at negative 3 and 4 at negative 3, and then we have 3 and 7 at 0, and there's our 5 points. I like 5. I could have gone to 2 more here if I wanted to, but now my vertex here is, I see it on the graph, I see it on the table. We can also say that my axis is symmetry, going all the way down here, my axis of symmetry is x equals 5, and because it crossed at that x-intercept there. And then you could say this is going to be a minimum, and the minimum is where y is equal to negative 4, because that's the lowest part of the line right there. Okay, let's move to the second problem. And you know, before we move to the second problem, let's actually try to find the vertex x value before we get to the calculator. So negative b over 2a with negative 2 is my b, so this is negative 2 over 2 times negative 1. So my hypothesis is that that's going to be positive 2 over negative 2. So my guess is the vertex is going to be at x equals negative 1, like my axis of symmetry right there. So let's look at negative 1 when we get to this next graph here. Everything goes away. Let's get to the calculator, go to the y equals. Let me insert a negative here so I can use part of this equation. Minus 2x and then plus 7. And there's my graph. It's going to be a frown. Negative 1 was the hypothesis for the vertex, and it looks like that's coming true here. Let's go to the table to validate that. And there it is. At negative 1, we have this symmetric looking table right there. So let's plot some points. At negative 1, we go all the way up to 8. At negative 3 and at negative 2 and 0, we're at 7. And at 1, we're at 4. And also at negative 3, we're at 4. And you could go one more spot if you wanted to. Negative 1 at 2 and there at and look, we got this beautiful parabola right there. So the vertex is exactly what we thought. We thought the x value was going to be at negative 1, but look, the calculator did a great thing. We could plug that negative 1 back into this. Negative 1 squared, negative of that, minus 2 times the negative 1 plus 7. That would have given us 8, but the calculator makes it easier. Then what we'll do is get the axis of symmetry, x equals negative 1, where that symmetry line is, and then what we have is the maximum. Since this is a negative a value, so the parabola opens down, the maximum's at where y is equal to, why did I put parentheses there? Y is equal to 8. There's your maximum at f of x, or y is equal to 8. All right. Let's go and do number 6's vertex hypothesis. Let's see where the vertex is going to be here. Negative b over 2a, so negative negative 5. A lot of negatives there on the numerator. And then 2 times 1, which is 2. So it looks like my vertex is going to be at 5 halves, or 2.5. Now this is important. Since my vertex is at 2.5, I'm going to have to change my table to see that. So let's go to my calculator. And again, I believe the vertex is at 2.5. So let's go x squared minus 5x. Go to my graph. It's hard to see from the graph that the vertex is at 2.5. See, when I go to my table, you'll notice that I'm going to get that cool symmetry, but I have a double number. You see how I have that double number here and here? That means the vertex is between 2 and 3. That's one situation that's possible. So go to your second window, and I would change the table. Instead of moving by 1s, have it move by 0.5s. Then you can really hone in on the 2.5, which I will do right now. And lo and behold, there's my symmetry. You see how 2.5 is in the middle, and I've got negative 1 and positive 1 and positive 4, both having the y values of negative 4. There's my supersymmetry, and that is going to get problem number 6 graph for me. So what that means is that I'm going to start off with a vertex at 2.5 and down 6.25, and that's going to give me way down here. All right, there's my 6.25. Now I'm going to choose my easy points: 2, negative 6, 3, negative 6. All right, and then I'm going to go 4, negative 4, and 1, negative 4, and here we go. Draw the parabola. Nice, and now I've got my vertex. Let's write that down before I forget it here. My vertex is 2.5, comma, negative 6.25, and then my axis of symmetry. I'm going to be a little careful with that one there. Yeah, it doesn't turn out so good at the end. X equals 2.5, and this is going to be a minimum where x is equal to negative 6. Why did I write that first? Negative 6.25. All right, 3 more to go here. Let's go get to, let's play this game here. We're going to go negative b over 2a to find my vertex, or at least my x-coordinate. So negative 4 over 2 times 1. So this is going to be 4 over 2. So my guess is that the vertex is going to be right at 2. So let's go take a look at this on the calculator. Let's type in x squared minus 4x plus 5. And here we go. Yup, my vertex was right at 2. Now let's go back to my second window, change the delta table, the change in the table to 0, and that is going to get my table, whoa, did I mean, change the delta table to 1. We're not moving by zeros, we're moving by ones. So we're going to start at 1. It doesn't really matter where we start since we got to move the table anyway. So let's go to balance this out right there at 2 in the middle. Here's my perfect symmetry. Look at this beautiful graph right there. Here's the graph again, and here's my equation. So let's plot these points. Again, 5 points is the minimum, but you're pretty much going to try to graph as many possible. So 2 is at 1, 3 is at 2, 2 is at 1, or 1 is at 2, 0, 5, 4 is at 5, and then the next one's at 10. I mean, it just can't get any better than this. So there we go. I guess it'd be better if it was a linear equation, but still, as quadratics go, this is pretty easy to graph. The vertex here, just as we had found out, the vertex here is going to be 2, 1. Again, I can plug my 2 in here and get 2 squared minus 4 times 2 plus 5 and get an answer of 1. My axis of symmetry is this line down here, so x is equal to 2. And then my minimum in this case, my minimum is going to be y. Again, why am I just jumping the gun there? My minimum is y equals 1 because that's the lowest y will be. All right, 2 more graphs to go here. Let's do some running. Oh wow, this is the first b value that hasn't been negative. So this is going to be negative b, negative 16 divided by 2a. So this is going to be, let's see here, 2 times 4. So my guess is that the vertex is going to be at negative, let's see, negative 16 over 8. So this is negative 2. That's where my vertex is going to be, negative 2. Let's go take a look at the picture here. Alright, sorry I did a little quick edit because I made a graphing mistake here. So I got my vertex at negative 2, negative 3. So negative 2, negative 3, there's my vertex. Okay, negative 2, negative 3. And I got a point at negative 3 and 1. And I've got a point at negative 1 and 1. And then it's so sharp here, 0's at 13. So it goes off the grid so fast. But it is a parabola, not a absolute value graph. It's not a V, it's a curved parabola. Just, you know, again, due to my graphic pen, probably not as good as your drawings. This is my axis of symmetry at x equals negative 2, and this is a minimum here where y is equal to negative 3. And one more problem to go here. Let's do a little run a hypothesis here about our negative, or about our x value here. So negative 3 over 2a, which is funny because 2 times 1/2 is just 1. It's just 1. So my vertex is going to be at positive 3. So let's go take a look at the typing in on the let's type it in on the calculator. This is going to be 0.5 x squared minus 3x plus 2. And delete that out there. Let's go to 3 and see where that vertex is. There it is, the vertex at 3. And now we're going to go get that down here and take a look. Go to 3. Get that symmetry rolling. Look at that. Beautiful symmetry in that table there. And now it's time to get our grid plotted. 3, negative 2.5 is my vertex. 3, negative 2.5. There we go. Vertex complete, which means my axis of symmetry is x equals 3, and this is going to be a minimum at y equals negative 2.5. All right, let's just continue plotting the points. This is going to be negative 2, negative 2. I'm just choosing some different points here. Negative, or positive, sorry, positive 2, negative 2. I got to be careful with these. Oh, shoot. Am I messing up? Yes, I am. There we go. Positive 2, negative 2. 4, negative 2. Let's see here. 6, 2. and then 0, comma 2. All right, there's 0, comma 2 there. I was too off there. Reading the graph wrong in haste. And there we go. Just shows you shouldn't rush math, even if you've been doing this for 20 years. All right, and there you go. There is your graph for problem number 9. All right, time to do 2 more problems down here, and we're going to use the power of the graphing calculator to make this happen. Using technology, find the x and y intercepts where applicable. Well, we already know the y-intercepts because these are the numbers that are here and here, but we're going to find the x-intercepts from the calculator. So again, you're probably going to need to use the negative b over 2a to find where you're going to look on the table for your vertex. So negative b over 2a, that's going to be negative 6 over 2 times a, which is 2. So 6 divided by 2. I'm going to look for 3 for my vertex here. So let's do one at a time here. Let's get the calculator up. All right, so here we go. I'm going to look for 3. So I'm going to type in x squared. Let me clear that out here. X squared. Sometimes it's just easier to start over. Minus 6x plus 9. And let's go to 3. That was my guess for the vertex. And wow, there it is. Right there, just because my vertex for the previous problem was 3. So my x-intercept is going to be at here. So now I'm going to focus on the graph. Now check this out. There's my x-intercept. My x-intercept coincidentally was the vertex of the problem. So my x-intercept is 3, 0, and my y-intercept is 0, 9. Check it out. You can see 0, 9. This is my y-intercept. This is my x-intercept. So I have it. My problem here is going to be done because now that I've seen it on the screen, my x-intercept is going to be, so x-intercept is going to be at 3, 0, and my y-intercept is going to be at 0, 9. Now in problem number 11, I already know my y-intercept just because the y-intercept is the last number in the quadratic order there. So the y-intercept is 0, negative 50. What about the x-intercept? Well, let's go look at the calculator, but where should I look? Let's go do the negative b over 2a rule. Negative 20 divided by negative 2, 2 times negative 2, because there's my 2a. So this is going to be positive 20 over negative 4. Looks like I'm going to be looking for my vertex around negative 5. So let's go look at negative 5 on my calculator. Again, all this is going to go away. Boop. And now what we'll do is type this equation in. Negative, now make sure when you type the equation in, it's a negative 2, not a minus 2, x squared minus 20x, whoops, not 2x, 20x minus 50, and then we go to graph to take a look at where 5 is, and look, it just touches that spot. So the so it's funny, the only x-intercept is at this spot, negative 5, 0, and our y-intercept is here, 0, negative 50. So let's write my formal answer to end our work here in chapter 8 in this unit. So this is going to be the x-intercept is going to be negative 5, 0, and our y-intercept is going to be at 0, negative 50. All right, I know this has been a long video, but thanks for sticking with it, and if you have any questions, email me.